Hello everyone, today is the day 4 of Transformer, and we know that Transformer core is made up of the laminations. Transformer core is made up of thin laminations, silicon steel sheets. Insulating material is provided between laminations to provide electrical isolation and to reduce the eddy current loss. So insulating material used between laminations is oxide paints, which is red oxide, inorganic paints, and thin impregnated paper. So what is the impregnation process? Transformer oil is added to insulation and this increases the dielectric strength of the insulation. This process is called as the impregnation process. Okay, to increase the dielectric strength of the insulation. Eddy current loss reduction. Lamination plus insulation break the eddy current path, hence eddy current loss is minimized. Cross-sectional area of the transformer core. So gross cross-sectional area is given by the AG is equal to length cross breadth. Net cross-sectional area is given by A, which is nothing but the area occupied by magnetic material, only magnetic material. Insulating material area is excluded. Flux passes only through the net cross-sectional area. So flux is equal to B into AN. AN is the net cross-sectional area, where AN is the net cross-sectional area. Stacking factor, which is called as the iron factor, which is the ratio of the Ks is equal to net cross-sectional area upon gross cross-sectional area, and which is given by A net is equal to Ag cross Ks, which depends on the thickness of the lamination. Okay, which depends upon the thickness of the lamination. Typical value ranges from 0.5 to 0.95 stacking factor. Okay, the range of the stacking factor is 0.5 to 0.95. Core staggering. What is core staggering? Punching and proper arrangement of lamination is called as core staggering. It ensures tight packing and uniform magnetic path. Effect of poor core staggering. So what happens if the core staggering is not done properly? If laminations are not properly staggered, thin air gap appears between laminations and reluctance of magnetic path increases and the excitation current increases. Transformer produces more noise. So what happens? Okay, and it gives to rise to the magnetic humming. Magnetic humming means transformer makes noise is called as a magnetic humming. Main reason is the magnetostriction phenomenon. Okay, let us see the magnetostriction phenomenon. Magnetic material slightly changes the dimensions and happens when subject to alternating magnetic flux. Okay, what is magnetostriction phenomenon? Magnetic material slightly changes the dimensions, happens when subjected to an alternating magnetic flux. So important points on noise. Frequency of noise is equal to 2 into the supply frequency. Noise level increases with increase in the flux density. Noise can be reduced by proper core staggering and proper design of the core. Okay, cruciform or the stepped core. So let us see the design of the core. First one is the cruciform or stepped core, also called stepped core. cross section is nearly circular. Advantages over square core: um, reduced magnetic reluctance and better utilization of core material, and reduced leakage flux, less noise and more space for winding. So what are the advantages of the square core? So reduced magnetic reluctance and better utilization of core material, and reduced leakage flux. So square core is more than the circular core, and less noise and more space for winding. So let us see some key points which are necessary or important from AE and JE exam point of view. To reduce the eddy current loss, we are doing the laminations plus insulation. Okay, flux flows through net only through the net area only, and noise causes magnetostriction. So what is the reason for the magnetostriction? Noise causes the magnetostriction. Noise frequency is given by twice into F, 2 into F, where Fs is the supply frequency. Okay, E net is given by, means net cross sectional area is given by cross sectional area cross stacking factor, where Ks is the stacking factor and whose value is 0.50 to 0.95.